Welcome to The Explainer. Today, we're diving deep into the sheer audacity, the incredible engineering, and the heavy-hitting economics behind one of the most transformative infrastructure projects on the planet right now, India's massive Mumbai-Ahmedabad high-speed rail corridor. We're going to unpack exactly what it takes to bring the bullet train to the subcontinent.
I mean, it's a monumental question, right? How do you actually build a 508-kilometer high-speed railway completely from scratch, cutting right through some of the most densely populated and industrialized areas on Earth? But what's really fascinating here is how this single mega project is forging a brand new template for the nation's future, laying down the technical capabilities that India will use for decades to come. At the end of the day, it's all about time. Right now, if you're making the journey between Mumbai and Ahmedabad by road, you're looking at roughly 6 hours. But by bringing in a train that operates at a blistering 320 kilometers per hour, this project slashes that travel time down to just 2 hours and 7 minutes. We're fundamentally talking about shrinking the economic geography between India's financial capital and the commercial gateway to the West.
So here's our game plan for today. We'll trace the route of India's first bullet train, unpack the crazy engineering behind this mega project, look at the true cost of all this speed, and finally zoom out to see the future expansion of the high-speed network.
All right, part 1, India's first bullet train, mapping out the 508-kilometer route. What's wild about this physical journey is the sheer verticality of it all. We actually start our trip 10 stories underground, 24 meters down, at the BKC station in Mumbai. From there, the train literally dives beneath Tain Creek through a 7-kilometer undersea tunnel. That's an absolute first for India, by the way. After that, it pops back up near Shilpada and glides onto an elevated viaduct that carries us practically all the way to Ahmedabad. Along the way, there are 12 strategically placed stations spread across Maharashtra and Gujarat. And they aren't just generic stops. They're heavily tailored to their locations. Take Surat, for example, famous for its gem industry, so the station literally has a diamond theme. Vadodara is built right next to the existing railway, so you can seamlessly swap systems without leaving the concourse. And Sabarmati? That's going to be a massive multimodal transport hub, converging bullet trains, metro, and local transit all in one spot. Now, you don't just flip a switch and open a 508-kilometer mega project all at once. It's a staggered rollout. The plan is to get the very first trains running on the Surat to Vapi stretch in Gujarat by August 2027. If everything stays on track, operations across the entire Mumbai to Ahmedabad corridor are expected to be in full swing by the end of 2029. Moving on to part 2, engineering a mega project. Let's talk precision and scale. 13.6 meters. To put that massive number into perspective, that is the diameter of the custom German-made tunnel boring machines digging that undersea tunnel we talked about earlier. These things are absolute monsters, some of the largest ever used for any railway project in India, chewing through earth 50 meters below the surface to create a single massy tube that'll house twin tracks for trains running in both directions. And the tech above ground is just as mind-blowing. The project heavily relies on proven Japanese Shinkansen technology. They're using what's called a J-slab ballastless track. Basically, that means no loose rocks, allowing the concrete slabs to be laid with a crazy microscopic tolerance of under 1 millimeter. Combine that with a top-tier ETCS Level 2 signaling system to automate safety and a specialized 25 kilovolt power setup, and you've got a system purpose-built for ultra-smooth 320 kilometer per hour operational speeds. But stepping back from that micro-precision, the overall macro scale is just hard to wrap your head around. Out of the 508 kilometers, a staggering 468 kilometers are entirely elevated up in the sky. The route crosses 25 different rivers and creeks. Near Sabarmati, the viaduct sits a towering 36 meters above the riverbed. Elevating the track like this is absolutely crucial to bypass the complicated land usage below, avoiding any disruption to established cities, traffic, and ecosystems. Which brings us to part 3, the true cost of speed. Let's look at the mega project economics. Okay, let's talk numbers, because unprecedented innovation of this scale definitely does not come cheap. The reality of building mega projects is that estimates can, and usually do, shift. The initial estimate for this project was about 1.08 lakh crore rupees, but as you can see, that cost has nearly doubled to an anticipated 1.98 lakh crore rupees. That's a massive revised budget that's currently awaiting final cabinet approval. So, who actually pays for all of this? Well, the bedrock of the financing is an 88,000 crore rupee loan from Japan's JICA, and that comes with a ridiculously low 0.1% interest rate. However, since JICA isn't providing extra funds for the newly revised budget, the Indian government is stepping up to absorb the significant cost overruns to ensure this project crosses the finish line. You're probably wondering what drove those costs up so much in the first place. Well, increased costs almost always go hand in hand with timeline delays. The original target was to finish up by 2022, but they hit some major headwinds. The two primary roadblocks: incredibly thorny land acquisition challenges, trying to negotiate real estate across two different states, and, of course, the sweeping impact of the global COVID-19 pandemic, which literally brought supply chains and labor to a grinding halt for a long time. All right, on to our final section, Part 4, expanding the high-speed network. Let's look at the future. Here's the big takeaway from all of this. The Mumbai-Ahmedabad line isn't just a one-off project. It's an operational master template. Tying perfectly into the Atmanirbhar Bharat, or Self-Reliant India initiative, the knowledge and standardized designs gained from this specific project are jumpstarting a whole new domestic manufacturing ecosystem. India is basically using this first line as a masterclass, learning how to build these complex systems locally to slash future reliance on imported tech. And we are already seeing this shift from theory to reality, thanks to the direct, hands-on experience of working alongside Japanese engineers on the current corridor. Domestic facilities like ICF and BML are tooling up as we speak. They're actively designing and manufacturing indigenous high-speed train sets capable of hitting 280 kilometers per hour, all right inside India. Having this homegrown capability is going to be an absolute game changer because a massive expansion is on the horizon. The government has already identified 7 new high-speed corridors across the country. Just look at these potential travel time reductions. Delhi to Varanasi in under 4 hours, Mumbai to Pune in just 48 minutes, Chennai to Bengaluru in just over an hour. We are literally talking about completely rewiring how a nation moves. And the financial scale of what's coming next is just breathtaking. Building out this nearly 4,000-kilometer nationwide high-speed network is expected to pull in a monumental 16 lakh crore rupees in future investments. It represents one of the largest planned infrastructure overhauls anywhere in the world right now, and it's all going to be built utilizing the standardized viaduct structures and supply chains currently being perfected in Gujarat and Maharashtra. So as we wrap up this explainer, I want to leave you with this thought. The country has a stated target of hitting 7,000 kilometers of high-speed rail by the year 2047. The 508 kilometers from Mumbai to Ahmedabad, that is just the very first stop. Consider how the crazy engineering marvels achieved deep underground and high above the rivers today, along with some hard economic lessons, are pouring the absolute bedrock for a hyper-connected India of tomorrow. The bullet train isn't just arriving, it's bringing an entire industry along for the ride. So what do you think this high-speed future will look like? Thanks for joining me on this deep dive, and keep your eyes on the rails.